Thank you. Thanks a lot for this introduction. And and Miraj, thank you for your really nice, comprehensive presentation on the possibilities we have with computational models, especially the field of computational Hadith studies. There's so much data outside that just need to be used, and we can see once we start doing it, we actually find patterns which are amazing. So we have been talking about Linked Open Tafsir again and again from different perspectives. Now I would like to give you a different perspective from not a humanities perspective. I put it general, but more from a mathematical point of view, coming to this question of how to deal with this historical data, or historical text. So I will present you the Tafsir data set, which has been created as part of this project. And I will talk about the task of named entity recognition and topic modeling for classical Arabic literature. So, okay, so that's right now. So I will give you first of all an overview on low resource languages. So what is actually the background of this whole topic? Then the annotation of named entities and topics. Sorry for this. I should have taken my own computer, but let's see. Maybe this is fine. Okay, so annotation of topics and named entities in classical Arabic literature. Then we'll come to the script-dependent optimization, and I think this is the more interesting part for our venue, because it's not too much dealing with the mathematical models and machine learning tools. We'll come talk a little bit about the results, and then the next steps. We can maybe also have a chance to think about how to combine our workforces. So from an NLP perspective, we can say that there are low resource languages, and the starting point is that most of the NLP approaches these days actually address high resource languages, such as English or Chinese, rather than historical ones. But this is not a good situation at the moment we have. We can say that all languages actually deserve equal technologies. There are many languages which are important for science, humanities, and theology, like ancient Greek, ancient Egyptian, Sanskrit, and in our case, classical Arabic. Classical Arabic was actually lingua franca of science and literature for a long time. So we have lots of treasure in this language, but it's just lying there and not touched by the digital technologies. So what is the consequence of this development? We have a gap between modern and historical languages, gap between modern and historical NLP. So in our work, we close this performance gap by first formulating annotation guidelines, which enable creation of Tafsir dataset to solve the task of NER and topic modeling in theology. Second, performing a large-scale annotation of the scanned historical theological books on exegetical studies of law, ethics, philosophy. And with this, we create over 50,000 of sentences to accomplish the task of NER and topic modeling. And this is the first kind of such large-scale classical Arabic data set. And third, we actually also analyze our data set and conduct a practical analysis of it. So let me give you, first of all, the text data source description. I mean, this is familiar to you. I don't have to go too much into this, but just still to repeat some of the points. So At-Tabari, in full, Abu Ja'far Muhammad ibn Jarir At-Tabari, is a famous religious scholar, author of encyclopedic work on early Islamic history of Quranic exegesis. So he consolidated theological thoughts during the 9th century, and he laid the foundation for both Quranic science and historical sciences. So his major work is History of Prophets and Kings and the Quran commentary, the Tafsir al-Tabari, which we are focusing here. So you can see this is the way usually you will find manuscripts. They are written here in a nice calligraphic way, and there's also some further notes on it. So this is the way we find the manuscripts. They are digitized, and now we make a big jump, and we come to our annotation environment, because what we want to do is we want to take this text and annotate it according to our defined categories. So you can see here now, this has been the working environment. You can see here, this is Abu Ja'far, it's a person. Muhammad sallallahu alaihi wasallam is a person, again. And then we have here Al-Yaman as a location. So this is just an example how you would annotate these texts in our annotation environment. So from this, we go to this, and next is what is the result of our annotation effort. So there are data sets available for Arabic, but they are mostly for modern standard Arabic. So that's the modern version of Arabic. But we don't have data for classical Arabic in such a scale. So we produced a really large data set which has 51,000 sentences with many persons. That makes sense. This literature, this genre mainly has many persons due to the isnads, but there are also many locations. We have the term of organization, so these are groups, and we have a definition of how to see them as a group, and then time and others. So this is the statistics of the data set, and then we also annotated the topics. So these are the topics. We have seen them on the first day. Here are some further statistics. I don't want to go into too much detail on this. And I see that I didn't include Israeliyat, which should be in the final version for sure. So this is a sample excerpt for the data set. So you see, you get a feeling how actually it looks like if you want to use this data set for the machine. So we have here topic matrix, which gives you per sentence. So this is a sentence here, written in this Connell format. And it gives you, for this sentence, the topics which occur here. So we have, for example, here, in this case, kalam. So in this sentence, the topic is kalam, but it's also lugha. So that's why we have 1 for these and 0s for the others. This is our decision to model it this way, because the models, which we will later use, they require such a format. So this is one part of the task. And we have actually many tasks here. So this is the second part. This is named entities. So we have Yom al-Qiyamah, which is a named entity of the category time, which is maybe also interesting to just think about that Yom al-Qiyamah can be a certain time. Yes, it is. So it is a named entity. And then we have our subtopics here. Here, Bi Murad and Bi Murabi. Okay, so I will not go too much into the detail of this data set and the preparation of it, and then let's say the feeding of the models. I will more focus on the script-dependent optimization, because I think this is something which is interesting also from previous talks we had. and also from your background, looking at the Arabic script from a historical perspective. So this is the most, we can say, modern version of the Arabic script, which is the vocalized version. So we have here Qala Ahmad Lun fi Makkatin Kulu Washrubu Haniya. We can read it. There's everything included in it: the vocalization, the dots, the jam. So now, if we start to remove this information, we can think of this as layers. So we have a script which has information in it, and we remove one layer, we get a new type of writing system, and then we remove another layer of information, and then we get this old version, which is called the Rasm. So the skeleton Arabic script. So this is now the question: how to, like, what is the value of this script? We had this talk also yesterday that is this script readable? Does it have enough information? And yeah, so all those different questions. We can say that what we know for sure is that this script has been the first one to document the text of the Quran. So it has a certain importance in any way, irrespective of if it's readable or not. So now I will come to the results. So I will come to this part later. First, let me just give you the overall results. When we use our data set, we get high values on the task, which is quite good, because that means that now we are able to identify all such informations, also from related literature, other tafsir books. But let me come to this more interesting result. So what we can see here, so we have trained the BILSTM network on our tafsir dataset. We have used the OpenITI embeddings, and for this I would like to thank Maxim Romanov again for providing this information and enabling also this setup of full training, because otherwise usually you don't have the chance to train a language model on such a scale if you don't have the data. So what we did here is we trained the model according to these three layers. So we have the vocalized layer, the standard layer, and the skeleton layer. And interestingly, what we can see is that actually when we remove the information from the layer and go back to the old script, the performance of the machine learning models is increasing and it's getting better. So this is actually contrary to what we would expect, that the vocalized version is the full version, you have all the information in it, but no, this is not the case for the machine. The machine actually needs this freedom of interpretation, so it can actually find the right meaning according to the context. So, yeah. So our conclusion in this, let's say, subtask is that from the machine learning perspective, the Rasm script is as good as the vocalized script. And if the machine learning model is able to understand the Rasm script, then humans can also do it. Back then they did it, and even now they would be able to do it after gaining sufficient training on this old script. So we can say that the Osmanic manuscripts were sufficient, and maybe they are still sufficient to get the original text of the Quran. So, yeah, thank you for listening.